Alright, polygon. So we have a polygon which is a closed figure with straight sides. So we're going on page 30 on your notes. A regular polygon is what you'll be typically dealing with, which will have all sides and all interior angles equal. Okay, that's straight off your note. So the first thing we need to talk about is the interior angle sum of a polygon. So the interior angle sum of any polygon is n take away 2 times 180 degrees. Has anyone seen this formula before?
No.
Is the number sides. Alright, so this is for the interior angle sum. Okay, so you add all the interior angles formed by the polygon, you add them all together, it'll be same as the number of sides in the polygon, take away 2 and multiply that result by 180. Okay, so let's have a look at the proof. We'd like to see how things work, not just take for granted that this is a formula. Okay, how did they come across the formula? The proof 4.5. Okay, so what's the smallest, what's the least number of sides for a polygon?
3.
3 sides, okay, which is called a triangle, okay? So interior angle sum, I'm going to write capital F, is what? 180, okay? So we've already proved that already this topic. Alright, so the next size up polygon has how many sides? 4, okay, let's draw any generic 4-sided polygon. Okay, it doesn't have to be regular. Right, and then with the angle sum of a 4-sided polygon is 360, and we proved that as well last week. Alright, next one up. We'll have 5 sides. Okay, a regular 5-sided polygon is called a pentagon. Okay, pent for 5. Alright, and now we need to justify the angle sum. How am I going to do that? Okay, what we've already proved this one using this property. So, can we put some diagonals in so that we have got the polygon made up of triangles? Okay, so I'll put 2 diagonals there, means inside that pentagon, irregular pentagon I got there, I have 3 triangles. Okay, so the angle sum is going to be 3 lots of the angle sum of a triangle. Okay, which is 540 degrees, of course. Okay, the next one is a 6-sided polygon, which we call a regular 6-sided polygon is called a, and we see these pretty common every day, whether you notice or not, with nuts and bolts and those sort of things. Okay, again, let's put some diagonals in so that we've got triangle. Okay, whatever best fits, but you should end up with 4 triangles in there. Okay, so the angle sum is going to be 4 lots the angle sum of triangle. Okay, so if 2 of them is 360, so we double 360, we get 720 degrees. Okay, so that means every single vertex that is made by the polygon, the sum of them all will be 720. Alright, so can anyone see the connection with the number of sides in a polygon with the number of triangles inside the polygon? Okay, so this one we have 4 sides and we have 2 triangles. This one we have 5 sides and 3 triangles. This one we have 6 sides and 4 triangles. Okay, so for any general n-sided polygon, okay, because there are 2 less triangles than there are sides, okay, so therefore for any n-sided polygon, the interior angle sum is equal to the number of sides hang on, if equal to 2 less the number of sides of triangle, i.e. Okay, so S is going to be n take away 2 times the angle sum of the triangle. Right, so that'll work for any n-sided polygon, regular or irregular. As long as the diagonals don't go outside of the shape, of course. Okay, so the other one that you need to know, the exterior angle sum of any polygon is equal to 350. Right, so it's property number 1. And this is property number 2. Okay, so no matter how many sides of the polygon you have, when you have the exterior angle, so we talked about the exterior angle result of a triangle. Okay, so we extend all the sides of the polygon. Alright, so I'm going to pick let's do a 4-sided. Alright, so what I'm going to do is extend the sides out in the one way. A, B, C and D. Okay, to extend one of your sides out, so if you have exterior angles, the angles outside of the polygon, and then from that result A plus B plus C plus D is going to be 360 degrees. Okay, that works for any polygon. I'm just trying to remember how to prove it now. Come back to it. Right, so we'll come back to the proof and look at some examples of applications of that formula. Right, example. Alright, start with A. Right, so sometimes you have diagrams, sometimes they will be worded questions and you need to know. So for example, the first one, it simply says find the angle sum, that'll be the interior angle sum of a octagon. Okay, so yes, you need to know how many sides an octagon has.
7. Like 9. That's 9.
Yeah, because an octopus has 9 tentacles, eh?
Oh yeah, yeah. One of them's head.
Alright. So an octagon has 8 sides. Alright, capital N for sum, which will be n take away 2, where n is the number of sides. So it's going to be 8 take away 2 times 180, so it'll be 6. What's the 180? We double 3 sides. So 3 sides 540, we double that. we're going to get 1080 degrees. Okay, that's just a straight application, and then coming up will be a next extra step that you need to work out. Right, B. Don't look like many people have got their notes in front of them. Alright, well you can rely on your notes when you look at them. Right, so we have a property of Hij. I don't really want to draw it, but anyway.
You pointed this out before.
Alright, everyone else can have a go at drawing that now. Everyone else can have a go at drawing this. Well, of course you have your diagram right in front of you, you can write in the diagram.
Stop this.
So you can draw that without lifting your pen off your paper.
Yeah, I can do it.
Thanks,
How did you...
Michaela.
Michaela, wow.
Genius.
Can you show... Michaela doesn't know how to do it.
Oh my god, Michaela.
Do I need to draw it again?
Yes.
Right, watching.
Do it without...
Watching. Ready?
Do it with your eyes closed. I want to see how smooth it is.
A-E. E-I. I-C. C-G. N-G-A.
I can never get them the same.
It's not meant to be the same, the diagram's not.
Yeah, no, but like, there's always one side that's impressively longer than the other.
Well, it is in diagram, so made it to look like that. Alright, angle jab. J-A-B. 29.
Yours isn't any better. It looks like you've just shown your star that's
B-C-D. E-37. D-E-F. E-32. F-G-H. E-26. Find H-I-J on that one.
Oh, what?
Yeah.
I need to figure diagram.
This is the
Diagrams should always be done much bigger than what's necessary.
I didn't I would have been smart if it's doing my shit. Thank you.
Oh, I did mine at home.
Alright, how are we going to do it?
I have no idea.
Any ideas?
Does it involve one or two?
might be stereo angle somewhere in Polygons.
We could do it that way, however I've identified a more simple way of doing it. Alright, angle GJC this one here is what?
Oh. 180 minus
180, take away 26 plus 37. Can anyone see the triangle? Okay, you want us to use those triangles so that we can get the angle sums?
Then
26 to 41. So 47, 57, and 63. 63, 700, and that.
What? Wait, 180 minus a sum
Yeah.
can't equal more than the original.
It's
147.
Isn't it like,
One one.
That was a 4.
isn't it 170?
73.
Eh?
Alright.
Isn't it 117?
I can bust out the calculator. Come on.
Because it's
63.
63. 180 minus 63.
So 63, 180 take away 63.
137.
It is 117. I was right.
117 does so.
Alright, 117. Alright, so this angle here, 117. Can everyone see why I'm getting that value?
Angle sum of the triangle.
Yep. Or simply I could have used my exterior angle result out here. Is that what you were saying?
Take a photo.
Yep. Okay, so what I really should have done was an angle IJH is going to be 26 plus 37, which is 63. The exterior angle result. Alright, so what's angle IHJ? What is this angle? What triangle are you going to use and what value are you going to use from that?
And that's G, that's H. Oh, I'm changing my J to an S. Sorry.
Might help. Can anyone see the triangle here? Where you're given two sides. Alright, so the exterior angle is equal to the opposite interior angles. So 29 plus 32. So it's going to be 62, 61. Now I'm very curious to see whether it's a because you could consider this five-sided polygon, whether that's going to give us the same answer if we did the interior angle sum. Anyway, therefore, angle IJK is going to be 180, take away the sum of 61 plus 63. 124, 56. Alright, just out of curiosity, someone with the calculator, can you please do the following?
IJK.
That plus that plus that plus that plus that.
Isn't it JIH?
Yeah.
180.
Said
Oh, sorry. Hope found the right angle. HIJ I needed. Yep.
It'll be 180.
Already written that.
Okay, can someone get a calculator please and add all the 5 points of the star together please?
180. 180. It's 180.
Yeah, 180.
It's just
180?
180.
So the property works.
How?
Smart one.
How?
Because this is technically what I drew was a 5-sided polygon. Pretty cool.
I just have to go through that one.
So if I did the angle sum of a pentagon, irregular pentagon, it's going to be 3 times, hang on, that one. Yeah, because 5 sides, take away 2, which is 3. No, that won't work actually, no. But it is 180.
It's Monday, isn't it? Yeah.
Interesting.
Why did it quit?
Right, see, find the size of each angle in a hexagon. If you're not told, you're assuming the interior. Okay, so how many sides the hexagon has? How many sides does the hexagon have?
20. Wait.
4 times 180. So 360, 720. Okay, so the angle sum inside a hexagon is 720. Okay, so hexagon is referring to a regular unless you're told otherwise. Right, so the angle sum of our hexagon, so all the angles together added together is 720. How am I going to work out the size of one of them?
6 divided by 720.
All the way around.
720 divided by 6. Yeah.
Alright, 720, the angle sum, divided by the number of angles it forms.
120.
120 degrees. Okay, so you need to make sure you read the question. It says find the angle sum, the angle of each, find the size of each angle inside in a hexagon. Okay, so you assume it's regular unless you're told otherwise. Okay, he hasn't told us otherwise, we can assume that we're referring to the regular, not the irregular.
Ribbon Olive's bad. What? Ribbon Olive's like
Was that what that story was about?
Yeah.
What the hell? It's
Right.
all random photos for.
Last one for this section.
Is it new?
Is it his
It's not
brand?
that boardable thing. It would be pretty fun.
Just no one bring the boards. No. We don't talk to long borders.
Yep. Okay, so find the for x.
I know this one. I know this one. It's a triangle. So it will be X.
So how I'm going to answer this question.
2x plus 72 is going to equal, what's it called? 360.
360.
Okay, the exterior angle sum of any polygon is 360. So we can use an equation. So we have 2x plus the two right angles, so 2 lots of 90,
Do you even need to do that?
plus 76 is going to equal 360. Okay? So the exterior angle sum of any polygon will always be 360. Okay? Okay, and the reason, the exterior angle sum of polygon is equal to 360 degrees. Alright, so to simplify, collect your like term, 180 plus 76. Okay, so instead of adding 180 and 76, because we know 180 is half of 360, okay, so I'm actually going to move the 180 over the other side. So we've got 2x plus 76 is going to be 180, so 360 take away 180. So rather than doing the sum and then taking away a bigger number, okay, so I can make things a bit more simple. Right, so 2x is going to be 104. X is 52 degrees.
No. Picked up my skateboard.
Right, any questions on polygons? One more section I need to do. Okay, so the last thing we need to do is area, so you should be familiar with all these concepts. Alright, so your formula sheet is there. On page 24, or 34 isn't it? 31. 31. Okay, so on page 31 of your notes, okay, are the formulas for the basic shapes. Yes, you need to know them. Yes, you should have covered them before in your junior schooling. Alright, so I'm going to go straight to the example and apply some of them. Alright. Alright, so one thing to clear up, when you find the area of a triangle, the formula is the half times the base times the height, because it's half a rectangle, it's half a parallelogram, half a square, however we say it. Okay, now it is always the perpendicular height from the base up to the apex. Okay, so if you are given this length here, that slope of that triangle, Nicole, if you are given the length of this slope, okay, you're not going to use it in your formula because you need the perpendicular height. Okay, so the base is 12 metres long and the height is referred to the perpendicular height of the base up to the opposite point of your triangle. Okay, so here we have a right angle, so that's the perpendicular height of 5 metres. Okay. Alright, so if you were given this one here, let's just say the variable x, alright, you're actually not going to use it. Okay, unless you need to use the application of Pythagoras or something. Alright, so half of 12, which is 6, 6 fives are 30, and you need your units, okay? So all answers should always incorporate units where possible. Okay, all answers should have fractions simplified unless you're told otherwise. And only when you're told, all answers are rounded. So, when you are told, you need to round any answers to a specified number of decimal places. If not, you leave it in the most simplest form. Okay, it's the most simplest third form, most simplest fractional form, whatever it takes. Alright, B. So we have a rectangle. Everyone should be able to do this one without any dramas.
Oh boy.
Okay. So going back to the polygon, the quadrilateral, sorry. A rectangle has opposite sides equal. A rectangle has opposite sides equal, opposite sides parallel, diagonals equal, and right angles in all the corners. Right, so everyone here should be able to do area of rectangle.
I wonder what this is.
Okay, however you want to write your formula, so 16 times 3.2.
You're drawn to scale.
Figure on by two.
32 plus 2.3.2. No. Yeah. 32 plus 3.2.
You got 50.
No, that's right. 32 plus 1.6. No, my mind's not cooking today. What do we get? 50.
1.2.
And don't forget your units. .2 and 48. Yep, 3.2 and 48, thanks. 51.2. Here we go. Alright. See?
It's Gavin absolutely loved.
For more reasons.
Alright, what type of quad do I have there?
What's it called?
I don't know what it's called, but it's got four sides.
Starts with T. Trapezium. So what's the property of trapezium? Only one pair of parallel sides, that's it. Okay, we know they're parallel because co-interior are equal. Sorry, co-interior are supplementary because those two angles are equal, 90 degrees. Alright, therefore we know those two sides must be parallel. And that's the only requirement for a trapezium, that we have one pair of parallel sides.
That one's cool. Easier.
Okay?
Whereas one goes like, yeah, everything's kind of parallel. Oh, one goes this way.
Different property involving different shape. Now, the area, half times the height times the sum of the two parallel sides. Okay? I'm pretty sure most of you would have done this in year 8 with me. And yes, you need to know these formulas because in Matthew Watt's Extension 2 paper in his HSC was requiring the area of a trapezium to start with. Okay? No, he could not remember the area of trapezium on a 4 unit paper. Alright, so half
Just go the wrong way. 1.2. 1.2 is 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 1.
Okay?
And just do it a long way.
Do it a long way.
Yeah, so like 5 meters times.
Or once your mind's set on a 4-unit paper, you just forget all the basics and don't assume all the basics either. Alright, so the height is the perpendicular height again between the two parallel sides. So because of the right angle there, is height, and then A and B are the length of the two parallel sides. So 15 plus 20. So you've got 4 times 35. So 70, 140. Don't forget your units, okay? Last I heard, the first time you make a unit error or you don't include your unit, you do not get your full marks for the question. You are then not subsequently penalised after that. I only have 35. Right, D.
And the two, the volume change of this. And then two, all the time also takes the mass. No, that's like weight.
Right. So how are we going to find the area of that figure? Good. Okay, so both has identified that there is a rectangle and a triangle made up of this figure. So what we need to do is break it up by putting some diagonals in. Okay, and then we can find the area of both those solids, the shapes, sorry. So area 1, area 2. Alright, so we have one pair of opposite sides equal. We have one pair of opposite sides, the same side parallel, because the co-interior angles are equal. They're both 90 degrees. Okay, now because of that, that's enough to state it's a rectangle. Okay. So, whatever the formula you want to use, there's no generic formula, just the two dimensions that make the right angle. Maybe 11 times 6, so 66 metres squared. Okay. Now because of the right angle, and we know they're parallel, we know these two must also be right angles, so that makes the other pairs of sides parallel. And because opposite sides are parallel, opposite sides must also be equal. Okay, so area 2, we've got a triangle, so half times the base times the height. Okay, so you've got to be careful what you make bases and height because you need the perpendicular height from the base. So if I let these diagonals that are drawn in the base, and then out here will be the height because these are the same dimension. Okay, like the same, going in the same dimension. Alright, so half times the base, which is the same as over here because of the rectangle, and then the perpendicular height will be the difference between 11 and 6. Okay, so 5. Now because they're both odd numbers, if I'm going to half one of them, I'm going to get a decimal answer, and again if I multiply two odd numbers, I'm then going to still get an odd number. So half 55, which would be 22.5.
Please, was it please?
It is 27, mate.
27, 77.5 metres squared. Right, so if you're not sure, you've got your calculator. Okay, last one I'm going to do. Alright, so you've got applications of area by finding composite area is what it's called. Alright, last one I'm going to get done today. Alright, what are you told? They're parallel. These are parallel. And you're also given a
Oh, I like this
5 metres. 18. Sorry, 25 centimetres. 18 centimetres. Right, so these are also parallel. And you're told these two are equal. Not the clearest diagrams. What else? You have that and that. 16 and 18. Okay, these wide diagrams need to be fairly big so you can fit all your information on it. Okay, so the area of a rhombus and the area of a kite are the same formula. Alright, because you've got adjacent sides here and you've got the diagonals given. Alright, so that's going to be a kite. It's only when all sides are equal and the diagonals bisect at 90 degrees, then you have a rhombus. Okay, now we also have opposite sides parallel on the larger figure. And if the opposite sides are parallel, the opposite sides must also be equal. And we can use a congruent triangle by doing diagonals here and here to then state angle side or something similar, and we can prove opposite sides are equal. Alright, so the question asked you for that shaded region. Okay. Alright, so it might be a garden bed of some sort, and in the middle you're going to put some concrete. Okay? Might be. Alright, so we got area 1, we can call that area 2. Okay, so because opposite sides are parallel, that's enough to say it's a parallelogram. Alright, so 25 times 18. Okay, so it is the base times the perpendicular height for the parallelogram, okay? Not the slant height, it has to be the perpendicular height to the top. $180, 360 plus 90, 360 plus 90, 450, is that correct? Good. Finally. Alright, centimetres squared. Alright, so area 2. We've got enough information for the kite, and the kite and the rhombus have the same formula anyway. Right? So the formula is half times the product of the diagonals. Okay? So in a kite and a rhombus, you are required the length of the diagonals inside the shape for the formula. Okay? Now, I've only written one, in the question, there's only one dimension on both the diagonal Okay, so you assume that it's the length of the entire diagonal. If it wanted from the corner to the centre, it would have written here 16 as well, and it would have written up here 18 up here. Okay, so unless you're told otherwise, you assume it is the length of the entire diagonal. Okay, so half times 18 times 16. 160 take away 16, 144. Sure? I can't verify that?
Yeah, very good.
Good. Alright, so to find the shaded region, so over here we had to add two areas and find this shaded region. So the area is going to be 450 take away 144. So 350 take away 44, so be 306. Don't forget your units. Alright, so that's enough to get you through chapter 4 now. So next week you have your assessment. Okay, everything that we did up to the end of last term, so everything we've done this term will not be assessed. Okay, so your chapter 4 exercises will be due, I'm going to give you a week after your assessment. Okay?
Are you going to give us like a practice assessment like before?
I'll see. Okay.